Playing around with a Rubik's Cube is a game of precision. I'm sure I'll solve the Rubik's Cube in no time now. There it is. Whew, I at least got one side right. In chemistry too, precise combination matters for compounds. Keep thinking. It is natural to be curious about constituents of an unknown compound and its ratio. For known compounds too, such information is used to do a check on their purity. Naturally, it becomes important after analysis to calculate percentage composition of each constituent element. Now, that is one important consideration for someone dealing with medicines. Today we will study percentage composition of constituents, determination of empirical and molecular formula, and of course, look at strategies to tackle exams in the exam decoded section. Well, I am not a pharmacist, but if I do need to find the percentage composition in chemicals, what formula should I use? Let's first study that. After that, we'll find the amount of each constituent as per compositions. The formula involved in calculating percentage composition of constituents is percentage of element. That is, mass of that element in the compound times 100 divided by the molar mass of the compound. Now, let's calculate the percentage of carbon and hydrogen present in phenol, the molecular formula of which is C6H5OH and its molecular weight is 94 grams. Calculate the percentage as per the first step. Step 1. The compound has 6 carbon atoms. Percentage of carbon is 72 divided by 94 times 100, which is equal to 76.59%. Step 2. 6 hydrogens. So, mass is 1 times 6, which is equal to 6. Therefore, percentage of hydrogen is equal to 6 times 100 over 94, which is equal to 6.38%. As phenol contains oxygen, so mass is 16, therefore percentage of oxygen is 17.02%. If we know the formula and molecular weight, percentage composition of each constituting component can be calculated. This is an important aspect in pharmacy, pathology, and all analysis where purity of a substance is involved. Earlier it was known that an element as a substance could not be decomposed by a chemical process. Simply put, if a chemist could not decompose a substance, it must be an element. But that is not the case anymore. Now we know about compounds which are formed when atoms of different elements combine with one another in small whole numbers. Moving on to the next significant concept, empirical formula. An empirical formula is a molecular formula reduced to the lowest common denominator. Let's make this simple. I have 2 hands and 10 fingers, or H2F10. The empirical formula for which would be HF5. The ratio of fingers to hand is 5:1. It is important to note that more than one substance can be reduced to the same empirical formula. To stretch our hand-finger analogy, we might have a two-handed person, H2F10, or an alien with 3 hands and 5 fingers on each hand, giving a formula of H3F15. The empirical formula for each of these would be HF5, since in both the cases the ratio is 5 finger per hand. Now let's illustrate this through a chemical example. Consider benzene and acetylene. Acetylene has a molecular formula of C2H2. We can get its empirical formula by simply dividing it with the lowest common denominator, which is 2 in this case. This gives us an empirical formula of C8. Similarly, for benzene, with molecular formula C6H6, we get the same empirical formula of CH, since in both the molecules, the ratio of carbon atoms to hydrogen atom is 1:1. Well, similar calculations with compounds are another story that we will tell you in a bit. Before we take a quick breather, here is a question. Find the percentage composition of benzene if the formula is C6H6 and its molecular weight is 78 grams. Why don't you work your way through this one while I'll take a break. You cannot plow a field by turning it over in your mind. So, unless you didn't think over the pre-break question, you won't have the answer for me. But for those who did, let's see if our answers match. We asked you to find out the percentage composition of benzene if the formula is C6H6, given that the molecular weight is 78 grams. Mass of 6 carbon atoms is 72. So, the percentage of carbon is 72 times 100 divided by 78, which is 92.30%. And mass of 6 hydrogen atoms is equal to 6. So, the percentage of hydrogen, which is 6 times 100 divided by 78, which is equal to 7.69%. It's time to take on compounds and calculations to do with them. Compounds are substances composed of more than one atom. Ratios of these atoms are fixed by chemical proportions of the elements. In the lab, ratios are determined by chemical analysis. It is the quantitative measure of chemicals which lead to their chemical formulas. This is how. Empirical formula is the simplest whole number ratio. For instance, molecular formula of benzene is C6H6 and its empirical formula is CH. The molecular formula of sodium oxalate is Na2C2O4 and its empirical formula is NaCO2. As explained earlier, the empirical formula is calculated from percentage composition of the constituting elements. If molecular mass is known, its molecular formula can be calculated. So, if you can visualize a molecule, molecular formula is a multiple of the empirical formula. Now, let's understand how to actually calculate the empirical formula. The first and the most important step is to use percentage composition in 100 grams. Then, convert it to moles using conversion factors with moles of atom. Now, divide moles of each atom by the smallest of the mole value. This might not give you a whole number for each atom. In that case, multiply by a suitable integer to arrive at a whole number ratio. So, we arrive at the empirical formula. Thus, N is equal to molecular weight divided by empirical weight. In other words, molecular formula is equal to N times the empirical formula. Yes, it's that simple, isn't it? Now let's take a look further by solving problems. A compound has carbon, hydrogen and oxygen only. Percentage of carbon is 52.14% and that of hydrogen is 13.13%. If molecular mass of compound is 46.028 grams, calculate the molecular formula. First step is the division of percentage composition with the atomic mass to get the mole value. Second step involves the division by the smallest mole fraction
to get the simple ratio. A third step may be required in some questions involving the conversion of the result of the simple ratio in whole numbers. This is done by multiplying with a suitable coefficient.
Thus we come to know that the ratio of carbon is to hydrogen is to oxygen in the compound is 2:6:1. So the empirical formula is C2H6O and the empirical formula weight is 46. As the molecular weight is 46, the value of N therefore will be 1. So the molecular formula is equal to empirical formula in this particular case. Now that's what I call a wow moment. But now is the time for a quick revision of the concepts we tackled today. Percentage of element is equal to mass of that element in the compound multiplied by 100 divided by the molar mass of the compound. Percentage is used for calculating empirical formula and molecular formula. Empirical formula is the simplest whole number ratio. N is the molecular weight divided by empirical formula weight. And N is the multiple of the empirical formula by which the molecular formula is calculated. That was quite a bit of learning, but have we really got all our concepts right? You already know that you can always go and log on to our website www.topperlearning.com and revise all the concepts you learn on our episodes. For now, let's try and solve some numerical problems. Let's begin with a simple one. Find percentage of each element in glucose, which is C6H12O6, the molecular weight being 180. Before you calculate, let's see what formula some students wanted to use to solve this problem.
And the formula to be used is percent of the element equals mass of the element into 100 divided by molecular mass of the compound.
Percentage of element is equals to mass of the element into 100 upon molecular mass of the compound.
Well, that was a good start. Many of them got it right. But let me explain the answer in detail. The formula to be used is percentage of element is equal to mass of the element multiplied by 100 divided by molecular mass of the compound. There are 6 carbon atoms, so the weight is 72. Therefore, mass percent of carbon is equal to 72 multiplied by 100 divided by 180, which is equal to 40%. Mass of hydrogen is 12. Therefore, mass percent of hydrogen is equal to 12 times 100 divided by 180, which is 6.6%. Mass of oxygen is equal to 16 times 6 is equal to 96. Mass percent of oxygen is equal to 96 multiplied by 100 divided by 180, which is equal to 53.3%. Percentage of each component will be carbon 40%, hydrogen 6.6% and oxygen 53.3%. So that's the sure short answer. But we have a student who posted this question on our website. Empirical formula of C6H12O6, CO2, HCO3, K2Mn2O4. Excellent question. And the answer is simple. They would be CH2O, CO2, HCO3, KMnO2. Remember the hands and fingers formula? That's just how you would want to solve this question. I am sure you have loads more to ask. So do I. A compound consists of carbon, hydrogen and chlorine only. Percentage of carbon is 24.27 and that of hydrogen is 4.07. Molecular mass is 98.96. Calculate the molecular formula. You think about the answer while we take a break. A clear thought process is the only answer to all problems. So I hope all your concepts are clear. Now here is the solution to the numerical problem we left you with. Given percentage of carbon is 24.27, percentage of hydrogen is 4.07. Therefore, the percentage of chlorine will be 100 minus 24.27 plus 4.07, which is 71.65%. So, our first step is to calculate the moles of carbon, hydrogen and chlorine. Then divide them by the smallest number 2.02. Hence, the empirical formula is CH2Cl and the empirical formula weight is 49.48 grams. Now we need to find the ratio N, which is equal to the molecular weight divided by the empirical formula weight. And we find that the value of N is 2. So our answer becomes, the molecular formula would be 2 times CH2Cl, which is equal to C2H4Cl2. Now that was quite systematic. It's about time we figured out how to tackle exams the proper way. Now let's take a look at some expert questions.
The questions which generally appear in the exam is that we have to calculate the atomic mass or the percentage of the element, for example, carbon in carbon dioxide, sodium in sodium chloride, calcium in calcium chloride. And this is what exactly has to be done. What the caution is that the calculation part should be perfect and you should take care about the atomic mass and the usage of atomic mass in the topic.
That sounds like quite a list. Let me add to it. An organic compound contains 66.7% carbon, 7.41% hydrogen and 25.9% nitrogen. The molecular mass of the compound is 108. Find out its molecular formula. An organic compound contains 32% carbon, 6.67% hydrogen, 18.66% nitrogen and 42.67% oxygen. Its molecular mass is 75. Find out the molecular formula of the compound. Make sure you get the right answer to all these questions. Now we are about to tell you how exactly to answer a question so that you get the maximum out of each attempt. If you get a question like this, an organic compound contains 75.2% carbon, 10.15% hydrogen and oxygen, what would be the empirical formula? This is how you must answer it. So, the empirical formula is, if you write all these steps as systematically as shown, there is no stopping you from scoring full marks. To sharpen your examination skills, log on to www.topperlearning.com and take our online tests. To round up our special tools on handling exams, we have some very special pointers that will keep you from going wrong. Try to analyze the given data carefully and remember the sum total of the percentage composition is always 100. So, if a compound is made of 3 elements and 2 percentage compositions are given, the third one can always be calculated by subtracting from 100. Empirical formulae are simple whole number ratios. If multiplying up to 5 does not give a whole number, you must recheck your answer. That should make formulation and calculation concepts crystal clear for you. Until we meet again, keep thinking and keep topping.